Good morning all. Welcome to the first class on digital electronics. What is digital electronics? What is meant by digital electronics? The branch of electronics which deals with digital circuit is called digital electronics. The branch of electronics which deals with digital circuit is called digital electronics. Now, before going to digital circuit, let us study what is an analog signal and what is a digital signal. What is an analog signal? Analog signal is a continuously varying signal. It can be either voltage or current. It is a continuously varying signal. For example, sinusoidal voltage. A sinusoidal voltage is a continuously varying signal, so it is an example of an analog signal. Let us consider an analog signal, a sinusoidal voltage. Which is drawn in the Vt axis. Now, from the figure, it is clear that the output voltage changes continuously. The output voltage changes continuously according to the input variations. Our signal is an analog signal, an analog sinusoidal voltage. The output voltage changes continuously according to the input voltage variation. So we can say that the output voltage can have an infinite number of values. The output voltage can have an infinite number of values. Now let us discuss what is a digital signal. Now, any signal, it can be either voltage or current. Any signal which can have only two discrete values is called a digital signal. So a digital signal is a signal which can have only two discrete values. For example, square wave. Square wave is an example of a digital signal. Another example is a transistor which is operating in saturation and cutoff. When a transistor operates in saturation and cutoff, that means the output voltage is either low or high. These two are examples of digital signal. So as an example, consider a square wave. with the maximum value 5 volt and minimum 0 volt. We can see that the signal has two values. The square wave has two values. They are plus 5 volt and 0 volt, which is evident from the figure. This plus 5 volt which corresponding to a high state and 0 volt corresponding to low state. In the previous section we have seen that when a transistor operates in saturation and cutoff, the output voltage is either low or high. So it is an example of a digital signal. So if proper digital signal is applied to the input of a transistor, then the transistor can be driven between cutoff and saturation. So to summarize, the digital operation has only two states, that is on state or off state. Now we have already discussed about analog signals. In an analog signal, the output voltage can have an infinite number of values. So comparing with analog signal, the digital operation is more reliable because the analog operation is many valued. So digital operation is more reliable than many valued analog operation. Now what is meant by a digital circuit? We can say that any electronic circuit that handles only a digital signal is called a digital circuit. Any electronic circuit that handles only a digital signal is called digital circuit. We can say that the digital operation is a two-state operation. Digital operation is a two-state operation. So what are the two states? The states are high or low. Digital operation is a two-state operation. The states are high or low, or on or off. The state can be also represented as 1 and 0. Now why it is called digital? Why the name digital? A digital circuit is one that operates the values. A digital circuit is the one that expresses the values in digits, ones and zeros. Hence the name digital. A digital circuit is one that expresses the values in digits 1 and 0. So it is called digital. So we have already seen that in digital system the digits 1 and 0 are used because there are only two states. Now the numbering concept that uses only the two digits 1 and 0 is called the binary numbering system. In digital system only 1 and 0 are used. Now the numbering concept that uses only the these two digits 1 and 0 is called the binary numbering system. So what is a binary number system? In a binary system, or a binary system uses only two digits 0 and 1 for counting the items. A binary system uses only two digits 0 and 1 for counting the items. The most common number system that we are using in day-to-day computing is the decimal number system. We are already familiar with the decimal number system because the decimal number system is used in everyday computation. In decimal number system, it uses the digit 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in decimal number system 10 digits are used. Now let us discuss the counting in decimal and binary number system. First consider a decimal system and then the binary equivalent of the decimal number. Now write the decimal number from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The binary equivalent of 0 is 0, the binary equivalent of 1 is 1, but the binary equivalent of the decimal 2 is 1, 0. For 3 it is 1, 1, for 4 it is 1, 0, 0, and for 5 it is 1, 0, 1. The binary equivalent of the decimal 6 is 1, 1, 0. For 7 it is 1, 1, 1, and for 8 it is 1, 0, 0, 0, and the binary equivalent of the decimal number 9 is 1, 0, 0, 1. Now let us discuss some terms, that is bit, nibble and byte. What is a bit? Each binary digit, it can be either 0 or 1, in a binary number is called a bit. So if we consider a binary number, then each binary digit is called a bit. Now a string of 4 bit is called a byte. A nibble. A string of 4 bit is called a nibble. Then 8 bits are called a byte. So a string of 4 bit is called a nibble and 8 bits are called a byte. So 1001 is a nibble and 10010110, it contains 8 bit, so it is called a binary byte. So a string of 4 bit is called a nibble and 8 bits are called byte. Why we study binary number system? It is because the binary number system is most useful in digital circuit. It is due to the fact that there are only two digits, that are 0 and 1. Binary number system is the most useful in digital circuit because there are only two digits, 0 and 1. Next, we will discuss about place values in decimal system and binary system. As an example, consider the decimal number 642. This decimal number can be expressed as we can write 642 as 6 into 10 raised to 2 plus 4 into 10 raised to 1 plus 2 into 10 raised to 0. Now, if we closely observe the number, we can see that each position has a value that is 10 times the value. Each position has a value that is 10 times the value of the next position to its immediate right. Also, we can say that the values of various positions in a decimal number system are powers of 10. The values of various positions in a decimal number system are powers of 10. Since a decimal number can be expressed as the power of 10, this number, that is the number 10, is called the base or radix of the decimal system. So in a decimal number system, 10 is called the base. So decimal number system is a base 10 system. That is, the decimal system has a base of 10. Now for decimals, we can describe LSD and MSD. So the digits to the extreme right of a decimal number, if we consider the digit to the extreme right, that is called least significant digit or LSD. So if we consider LSD, that is the least significant digit, the positional value or weight is the lowest. So for decimals, the digit to the extreme right is called the least significant digit, and for the least significant digit LSD, the positional value or weight is the lowest. Similarly, we can consider the leftmost digit in the decimal number. The leftmost digit in the decimal number is called the most significant digit, MSD. The leftmost digit in the decimal number is called the most significant digit, MSD. So for MSD, the positional value or weight is the highest. That is, for LSD, the positional value or weight is the lowest, and for MSD, the weight is the highest. Let us revise the previous example. In 642, LSD is 2, MSD is 6. Now let us consider the place value in a binary number system. We have already seen that in binary number system, only 0 and 1 are used. Since there are 2 digits are used, we can say that the base of binary number system is 2. So in a binary number system, each position has a value that is 2 times the value of the next position to its immediate right. So in a binary number system, each position has a value that is 2 times the value of the next position to its immediate right. As an example, consider a binary number 1001. As an example, consider a binary number 1001. Since the base of binary system is 2, we can express this binary number 1001 as 1001 equal to 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0, which is equal to 9. That is, the decimal equivalent of the binary number 1001 is 9. Now for binary numbers, the digit at the extreme right is called least significant bit, or LSB. The digit at the extreme right is called least significant bit, LSB. Similarly, for a binary number, there is a leftmost digit. The leftmost digit is called most significant bit, MSB. So in binary numbers, we have LSB, which is the least significant bit, which is the digit at the extreme right, and MSB, which is the most significant bit that corresponding to the leftmost digit. So in the number 1001, LSB is 1 and MSB is 1. Now, this is enough for today's class. In the next class, we will discuss about binary to decimal conversion, decimal to binary conversion, and some idea about logic gates.